welcome back to Well, That's Interesting. We love a first on this show, and wow, that's a first edition. Today is episode 277. These paired roaches show commitment through cannibalism and aggression, and in this parasitic species, every ant is a queen. My friends, if you were with us back in February during episode 267, you should still be cooling off after our wild embrace of two studies suggesting the act of kissing could be traced as far back as 21 million years, and thanks to an ancient shark, some 439 million years ago, we have the jaws we have today. This was all in celebration of Valentine's Day, and you know what? If I had seen the cockroach study we're about to cover back then, girl, I would have squeezed it in, because if you're a longtime listener of the show, then you know nothing says love like the consensual alteration of someone close. Have a listen to episode 163, Comb Carved from a Human Skull, and or episode 258, These Smoked Human Remains Are the Oldest Known Mummies So Far, because those are just a few examples. Today is another. In the first half of the show, when I say creatures that mate for life, what comes to mind? Swans, maybe? The Eurasian beaver, perchance? How about coyotes and the albatross? Yeah, just like some of us humans, they engage in lifelong monogamy. And side note, if you thought to yourself, wait, what about penguins? You're close. Those wobbly business geese are more into serial monogamy, meaning they typically pair with one partner per breeding season, and may choose a new one the following year. And if that broke your heart, please don't shed a tear. I have another little creature that is so fiercely loyal. They express their passion in ways that leave even the most seasoned behaviorists muttering the words, "That's just too much." That creature is Algania taiwanensis, a wood-feeding cockroach. Yes, a cockroach, whose commitment ceremony involves what a research team has dubbed mutual wing eating, which is exactly as it sounds. Before, sometimes during, and after mating, a male and female pair will take turns consuming each other's wings. Thereupon they will build a home inside decaying wood, raising offspring together and defending their nest. If this raises your eyebrows, you are not alone. This species is the only known bug who engages in lifelong partnership. And boy howdy, we need to get into the studies that prove it and show just how far they'll go for one another. We will meet the hot-for-insects entomologist who stumbled on a pair of wingless lovers during a stroll through the forest. We've all been there. And thanks to her own devotion to these crawlies, we will partake in a study that confirms their missing limbs were due to affectionate cannibalism. And yes, we will go over a few theories as to why they would partake in each other's bits. We will then reunite with the same entomologist because she just couldn't quit S. taiwanensis. And we will be so glad because the results of her second study feel like they're an episode right out of the reality TV series Housewives. What happens when you expose a paired couple to a single male or female? Yeah, you guessed it. Shit hits the fan. Not for the couple, no. You will need to see the takedown of the interloper. Grab the popcorn and get ready for hands and a whole lot of love. Then after the break, we have been covered in ants lately, and I have to say, I have absolutely no problem with it. The recent discoveries about our tiny underground neighbors have been nothing short of extraordinary, proving these little fuckers live on a totally different level. Back in January, during episode 265, we learned of a parasitic queen who Tom Cruises her way into the colony of another ant species to turn every worker against their true mother. Back in March, during episode 273, we learned why and how diseased baby ants tell their nestmates to kill them. Yeah, what a day that was. And if you top all this off with episode 257, where our minds scrambled at the idea that Queen Iberian harvester ants can clone completely different species of another ant, you might just say to yourself, what in the holy hell can be next? Well, I've got you. If we combine a little bit of each of those stories together, we have the second half of this show. Just this year, researchers have discovered the first known ant species consisting exclusively of queens. and they reproduce through parthenogenesis, meaning they produce female offspring from cloning themselves. No workers, no males, just lady queens. So, one must ask, how do they do it? How does a single queen successfully build a colony of queens? We will get into it. We will meet the international team that joined forces to find this ant, which at the time was only rumored to behave in such a fashion. We will sneak into their experiment the same way Temnothorax kinomuri sneaks into a host colony. That's the name of the ant, by the way. We will bear witness to what this queen does to overpower her enemy, and we will leave amazed as to why she has evolved this way. It is brilliant and violent, and it has all the makings of a TV series itself. In the meantime, hi, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my whirlwind business goose. To begin, I'm going to ask you to clutch your passport and to bring along your favorite hatchet, because I'm dialing the time machine way the fuck back to a time unrecognizable, 2014. And we've just gracefully landed in what looks to be the Brazilian rainforest. But my friends, the lush greenery currently enveloping us, the equally thick humidity choking us, and the sound of distant waterfalls is misleading. We are nowhere near South America. We are several paces behind Haruka Osaki, a newly christened biology student, who for the past year has taken up the hobby overwhelmingly fitting for a budding scientist. With an axe and bloodlust for rotting logs, she's been taking long walks in Yambaru National Park, collecting insects that strike her fancy. And for my fellow geographically challenged Americans who feel maybe we shouldn't be following someone hacking away at their surroundings and are wondering where Yambaru National Park is exactly, don't worry, I've got you. The situation is totally harmless, and by the end of this segment, you'll be physically safe, but comparing the devotion of partners, current and past, to certain wood-eating cockroaches. I'm sure they'll live up to it. Anyway, where are we? Everyone please imagine the shape of Japan, which is something of a comma. Thank you. Point to the very southern tip and zoom in. Here is the island of Kyushu, whose very own northern tip is home to the aptly named Kyushu University, one of Japan's leading research-oriented institutes, run by a whopping 8,000-member faculty and staff, and boasts a 19,000 student body population. One of those is Haruka Osaki, who is off campus and currently focused on bringing back specimens from Yambaru, located on a completely different island. So please, everyone, zoom out. Perfect. From the end of that comma, I'd like you to sprinkle a few dots, also in the shape of a comma. There in the middle is Okinawa, whose beaches can be confused for Hawaii, and whose interior rainforests mirror that of Brazil's, but they very much stand on their own. They go by the nickname of Miracle Forest, as they are a vital habitat for endangered species, including the flightless Okinawa rail, Okinawa woodpecker, and the Yambaru long-armed scarab beetle, who, like its name suggests, has two uncomfortably long front limbs and is one of the rarest beetles in the world. It's no surprise, then, why Haruka is here once again, after a full year of poking and prodding dead foliage. On this day, in 2014, her persistence paid off in spades, eventually leading to what will be considered the first ever proof of what her study describes as, quote, demonstration of selective aggression as a behavioral component of selective social association in an invertebrate, end quote. Now, what the hell does that mean? we will get to it. But in the meantime, let's start at the beginning, where Haruka has just hacked away at a log and found the following. Please, drop whatever sharp object you're holding right now and pick up your phone. Type on today's episode post, and in the first photo, you're going to see a very common sight. Go ahead, I'll give you a second. Oh yeah, sorry, I should have warned you about that. It's a roach. Actually, two roaches. Now, what we see here may resemble the classic roach, but these, as we will learn, have a particular behavior that sets them apart from the rest. My friends, it is my honor to introduce you to Salginea taiwanensis, or the Asian wood-feeding roach. Adults are dark brown to nearly black in color, roughly an inch in length, and most notably, newly emerged adults have fully developed functional wings. One example is the roach on the right in that photo. There it is, fully cloaked in two shiny, transparent appendages. The one roach on the left there, though, as you can see, there's something off about it. Its wings have completely vanished. Something similar is what Haruka had stumbled into. As noted in an interview with Elizabeth Preston of the New York Times, quote, "When I caught the wood-feeding cockroaches in the wild, I noticed that their wings were chewed by something." End quote. Well, I think it's safe to say the average non-bug-loving person like you and me would simply shrug off this finding as a supposed injury, maybe inflicted by a predator. But not Haruka. Oh, no. She's so into these types of creatures, her interest has surpassed mere collection and learning about their biology that it full-on swan-dived into insect drama and all the rumors that come with it. In that same interview, Haruka mentioned at that time, word on the street was that this damage probably didn't come from predators, but from these roaches eating each other's wings as a nuptial act. You heard me. That was the rumor. These bugs engaged in mutual, consenting cannibalism to signify their lifelong commitment to one another. But despite how salacious that sounds, no one has ever looked into it. I mean, yes, what's called sexual cannibalism is very well documented in invertebrates and is very, very one-sided. It usually entails a female consuming a male either before, during, or after courtship. If spiders come to mind when I say this, you are right. Such incidents have been observed in around 30% of matings in the wild and as high as 58 to 75% in lab settings. And it's not only our spider friends that get down this way. A 2016 study by William Brown and Catherine Barry on the Chinese praying mantis found that females cannibalized males in up to 50% of matings. And as to what the leading theory is as to why sexual cannibalism happens? Well, why not? Females needing extra energy for eggs get a boost in nutrients, and males have a greater chance of being a dad, although posthumously. But here, with S. taiwanensis, we might be dealing with something completely different. Neither the male nor female is being consumed until death. Rather, each is allowing the other to consume their wings, and they move in together. That is, if that's really happening. Inquiries must be made. So, are you interested? Of course you are. Luckily for us, we don't have to lift a finger or handle a roach. We could leave that to Haruka, who also felt this was an experimental opportunity for the ages, and could be one hell of a doctorate. So, years later, from that moment in 2014, Haruka returned to the Okinawa forests with her trusty hatchet and a team of hot-for-monogamous bugs on the lookout for as many premature S. taiwanensis roaches that they can get their hands on. And they struck lucky gold. Dozens of nymphs were collected from Yona Field and were flown back to the university's labs where they matured into adults. Wings intact, 24 male-female pairs were arranged, and cameras began to roll. Oh yes, as documented in Haruka and the gang's aptly titled paper, Mutual Wing Eating Between Female and Male Within Mating Pairs and Wood-Feeding Cockroach, the team set up the insect version of 90-Day Bay, but for a more reasonable 3 days in front of cameras, hoping to catch any glimpse of said mutual wing eating. And, like 90-Day Bay, everyone involved got way more than they bargained for. All but 3 pairs went to town on each other's wings. And 12, yes, 12 literally fully committed by consuming as much wing material Haruka recorded in wild pairs. So are you curious as to what was seen exactly? Too bad. I'm going to tell you all the steamy details of this cockroach courtship, so buckle up. From their paper, published in the January 2021 issue of Ethology, quote, Salgania taiwanensis ate its mate's wings in the following typical sequence. The actor is the individual that is actively eating the wings. The recipient is the mate of the actor. Step 1. The actor approached its mate, exhibiting antennaing. Which, don't worry, I gave a Google. This is when insects use their antenna to tap, touch, or smell other insects or their surroundings. It is a vital close-range communication method, and as we're about to see, it's sometimes used in bug foreplay. See Step 2. Step 2. The actor licked its... Oh, God. The actor licked its mate's body parts once discovered. The body parts groomed were the head, pronotum, abdominal tergum, wings, and legs. This step was occasionally skipped, meaning they went right to it, and what I mean is step 3. Step 3. The actor climbed onto the recipient's back and ate the recipient's wings. Step 4. During step 2 and 3, the recipient did not walk. The recipient did lean either toward the actor or toward the opposite side of the actor. Step 5. The actor stopped eating although its mate's wings were partially intact. In 61.7% of the times of stopping, the recipient remained motionless. In the other 38.3% of times, the recipient wagged its body left and right. After the recipients wagged, the actor stopped eating more often. End quote. So you heard me right in step 5, even roaches understand consent, which is amazing. Also amazing, Haruka had proven the rumor to be true. The sequence I just read from step 1 to 5 was defined as a single bout of wing eating, and both males and females performed several rounds of bouts until the mutual wing eating was over. Now, at this point, you probably have a few thoughts like, why am I listening to this? And why exactly do they chew each other's wings off? What is it so a mate can't flee or something? Well, great theory, my amorous business goose. That could be a possibility, as so bluntly explained by Elizabeth Camillo of Smithsonian Magazine. Quote, without wings, the cockroaches can no longer fly, which eliminates one of the best resources for escaping predators and finding food. So even if one of the roaches did have a wandering eye, they wouldn't last very long on their own. With nowhere to go safely and limited options for scavenging, these two wingless lovers don't have many options besides sticking together, making lots of babies, and raising their young together. End quote. Now, I have to admit, framing it that way does sound pretty goddamn awful and confining, but there are some practical, optimistic explanations as well. These roaches spend their entire lifespan of 5 years in a dank, dark, rotting log that's home sweet home. And yeah, they live for 5 years, which is about the same length as a guinea pig, which is fucking crazy. Anyway, it's possible removing their wings lowers the chances of getting snagged in these tight quarters and also reduces the opportunity for mites and parasites to latch on, hitching a ride to the newborns. So technically, a paired couple has it all. A home, food source, and family, so neither really has to leave the log again. Perhaps mutual wing eating is a way to signal they're ready to settle down, and as a way to help each other out. If this is the case, that their pairing is full commitment, there should be no sexual conflict, meaning neither the male or female strays into the 6 arms of another roach. But how do you prove something like that? If you said we need another reality TV situation that this time is giving Temptation Island, you're absolutely right. So join me now, will you? Back with Haruka, whose own commitment to these roaches is borderline obsessive, and I am here for it. The year is now 2025, and you need to see what Haruka and the gang came up with for this experiment. So please, drop whatever loved one you're holding right now and pick up your phone. Tap on today's post and swipe past the portrait of S. taiwanensis, and what you're going to see is a makeshift petri dish that's designed for drama. I will give you a second. Yeah, it's incredible, isn't it? Now, for those who are still holding their loved one for some reason, don't worry. I could explain what we're looking at. Imagine a rectangular petri dish divided into 2 rooms. The room on the left is the larger of the 2 and is literally the love nest of 2 paired wingless roaches. The room on the right is more studio-sized, perfect for a single winged bachelor. This was the experiment. 10 pairs that completed mutual wing eating within 24 hours were given the room on the left, while what Haruka and the gang labeled the intruder was housed in the room to the right for 10 minutes before the partition was removed. So, what happened when the newlywed couple was exposed to both male and female intruders? Drumroll, please. Thank you in the back. Violence. So much violence, quote, all copulated post-eating pairs displayed vigorous ramming of intruders. engaged in both intersexual, male-on-male, female-on-female aggression, and intersexual, female-on-male or male-on-female aggression. In contrast, among pre-eating pairs, only one non-copulated pair showed male-to-male aggression, and the only copulated pre-eating pair did not fight. End quote. From their new study, aptly titled Exclusive Aggression Against Intruders in Cockroach Mating Pairs Following Mutual Wing Eating. Yes, that is the title. You heard me right once again. Both of the paired males and females that engaged in wing eating beat the ever-loving shit out of each bachelor and bachelorette, proving that true love and full commitment is possible. I mean, proving that, quote, immediately following mutual wing eating, individuals do not accept alternate mate candidates. This study provides the first experimental demonstration of selective aggression as a behavioral component of selective social association in an invertebrate, end quote, also from the paper. And that's what I said at the top of the show. And now it makes sense. Yay. May we all find someone who treats us like wood-eating roaches treat each other. Oh. After the break, we are leaving the loving abundance of one insect for the fierce independence of another. But we are sticking in Japan, and we are once again testing a rumor. For decades, under laboratory conditions, one particular species of ant had the habit of only producing queens. That's right, one queen replicating herself and producing no workers or males. These queens also refused to mate, but nonetheless, the queens kept coming. Was it thanks to the confining conditions of these labs, or is it truly their behavior, like in the wild? Someone finally looked into it. Another first is next. Stay tuned.
Blowing ad budget on metrics that look great till the CFO sees them, that's bull spend. And marketers are calling it out in Dashboard Confessions.
I remember telling my boss, it'll be good for the brand, when leads were slow. Yeah, it wasn't.
Cut the bull spend. LinkedIn lets you target by company, job title, and more. Advertise on LinkedIn. Spend $250 on your first campaign and get a $250 credit. Go to linkedin.com/campaign. Terms and conditions apply.
Halliday presents, in the red corner, the undisputed, undefeated Weed Whacker Guy. Champion of hurling grass and pollen everywhere. And in the blue corner, the challenger, extra strength Halliday. Eye drops that work all day to prevent the release of histamines that cause itchy allergy eyes. And the winner by knockout is Halliday. Halliday, bring it on.
And we're back. We are so back. And my friends, I'm going to have to ask you to leave all that devotion we spoke about in the first half of the show at the door, because right the fuck now, it's every lady for themselves. So please, join me, will you, back at the archipelago of Japan, which, fun fact, consists of 14,125 islands. However, the species of ant we're about to get into is so rare, it can only be found in 9 of these locations. As such, entomologists and hot-for-bugs nerds alike have been adding this prized possession, called Temnothorax kinomuri, to their collections for the past 40 years. In that time, for over 4 decades, no matter who took role of keeper, the reproductive and living situation of T. kinomuri has remained the same. Isolated, a queen would still lay eggs, and when those eggs hatched, the pupa grew into queens themselves. Refusing to mate or perform tasks of workers, these queen copies would separate, seeking out the colony of a related species called Temnothorax macora. Inside this foreign nest, with Viking-level courage, Kinomuri would kill as many soldiers and worker ants that confronted her. If she succeeded in this rampage and found herself before the true queen, a battle would ensue. If victorious, T. kinomuri would find herself reigning over thousands of workers, doing her bidding and caring for her brood. Which, by the way, upon hatching would still be queens. Now, what's called parthenogenesis is a very well-documented phenomenon, having been witnessed in a number of creatures, including whiptail lizards, Komodo dragons, sharks, aphids, bees, birds, plants, and yes, ants. It's a form of asexual reproduction where embryos develop from unfertilized eggs. Now, in sexual reproduction, an egg uses sperm to provide a second set of chromosomes to make a full genetic set. But in parthenogenesis, a female's egg is like, girl, I got this, and completely skips that step, preferring one or the other of these options instead. There's the double-up method, or automixis method, where the egg splits normally, but then instead of using sperm, it merges with one of its own leftover cells, called polar bodies, to get the full amount of DNA needed to grow. Because of this reshuffling during the process, the offspring might not be exact clones, but they are genetically very close to the mother. Then there's the skip the split entirely method, or apomixis, where the egg, skips the normal reduction process entirely and develops directly into an embryo by creating an actual clone of the mother. As to when and why this takes place, we humans can only theorize by looking at patterns. Parthenogenesis seems to be one hell of a tool to have in your toolbox for when the environment becomes challenging. For example, when you can't find a member of your own species, thanks to, let's say, habitat destruction or natural volcanic activity blotting out the sky. In sum, it seems to be a crucial survival mechanism that allows a single female to establish a new population. So, is that what's going on here? In these collectors' homes and labs? Was Kino Murai just reaching into her bag of tricks because of the unfamiliar environment? My haploid business goose, no one asked until 5 minutes ago when Keiko Hamaguchi, a biologist at Kansai Research Center in Kyoto, Japan, Jürgen Heinz, a biologist at the University of Regensburg in Germany, and their colleagues were like, "Are you serious? No one's checked to see if she does this in the wild?" Ugh. Fine, I'll do it. And do it, they did indeed. Between 2022 to 2024, Keiko and the gang collected 6 colonies run by T. Kino Murai queens in 6 of those 9 locations and kept them in nest boxes at their lab. According to the study, when the eggs of those colonies hatched, 43 offspring were produced in total, and I'd like you to guess what those babies were. If you said queens, you are absolutely right. From the aptly titled paper, A Parasitic Parthenogenetic Ant with Only Queens and Without Workers or Males, quote, "From the collected brood, we obtained 24 gynomorphic and 19 intermorphic offspring queens, but no workers or males. A close examination of the genitals of the pupa ruled out the presence of morphological queen-like males," end quote. My friends, that is just a fancy way of saying we gave these pupa quite a pokin' and a proddin', and wouldn't you know it, 24 had bits that exhibited typical ant queen physical characteristics with wings, or gynomorphic, while 19 were wingless ant queens, or intermorphic. So here the team stood with 43 queens on their hands. The only thing left to do was test the final part of the rumor, that these royals demanded a colony of their own. And to get it, they'll stop nothing short of murder. Fun. So join me now, will you, at the second half of this experiment where, quote, 43 lab-reared, definitely unmated daughter queens were given the opportunity to take over a T. macora colony or groups of T. macora workers and brood under controlled conditions, end quote. So, what happened when a single invading queen met a possible host colony? Drumroll, please. Thank you in the back. Violence. So much violence. Despite giving it their all, only 7, just 7 of the 43 came out alive and victorious. But get this, 7 was enough. Those 7 queens went on to produce a total of 57 offspring, which were also, you guessed it, all queens. My friends, if you are impressed, you should be, as Jonathan Ramiguire, an evolutionary biologist at the University of Montpellier in France, who wasn't involved in the work, told Live Science via email, quote, "Yet, until now, no species had been shown to merge both strategies, that being parthenogenesis and parasitism, despite the intuitive evolutionary logic behind such a combination." End quote. Yeah, in the 15,000 known species of ants, T. kinomori truly stands out. We know of no other ant or creature that lives this way. And by all accounts, she's doing great. May this bloodthirsty single queen be an inspiration to all of us. And thank you for listening, rating, subscribing, following, telling your friends about commitment, like what true commitment is. And get as graphic as you can. And then follow up by saying, you know what? Sometimes you just need a parasitic queen and have children of your own that are the same. Exactly the same. Somehow it works. And a ballooning thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you love the other podcasts in this family, and please, stay interesting.